In this video, we're going to review centroids. So what is a centroid? A centroid is a geometric property. It is the geometric center of some area, which we will denote with the letter A, capital letter A. The formula for the coordinates of the centroid can be found from the following formulas. And the centroids themselves are denoted by x and y over bar. So x over bar and y over bar. The equations for x over bar and y over bar are as follows. So x is equal to the integral of x tilde dA divided by the integral over dA. And y over bar is equal to the integral of y tilde dA over the integral of dA, where x tilde and y tilde are the coordinates of the centroid of each element. So the shape is broken up into many small elements, and x tilde and y tilde represent the centroids of each of those elements. So let's do an example that will hopefully make things more clear. So here we're going to find the y centroid for a triangle. Okay, so I'll draw our triangle here. We have our y coordinate here. We have our x coordinate here. The coordinate, or the triangle, has a base of b and a height of h. So this is our triangle. We would like to find the y, or the coordinate of the centroid in the y direction. And one more thing to note here is that this line is defined by y is equal to h over b times b minus x. And I'll just also make a quick note. We can solve that for x to find that x is equal to b over h times h minus y, which will come in handy later. So we are going to consider a rectangular element with some thickness dy. So this element we'll draw here, we'll draw here in, we would draw that in blue. Some element which has a thickness of dy, and it ends in some point here, which is xy. So we're thinking about this element, and we can first think about the area of that element. So the area of that element is dA is equal to x times dy. dy is the thickness, that vertical thickness of the element, and x is the width of that element. And we can rewrite this using our expression right here for x as b over h times h minus y times dy. So that is the area of our element. And further, we can write down the centroid of that particular element. So its centroid is a distance of y tilde is equal to y from the x-axis. And we know that because this point here is point xy, right? And so that is the centroid of that smaller element. So now we can apply our equation up here for the y centroid, y bar. So we will apply the equation. Y bar is equal to the integral of y tilde dA over the integral of dA. And when we do that, we we integrate this from 0 to h. We know already, we found that y tilde is equal to y, and we also derived this expression for dA, which we found is b over h times h minus y times dy. And then in the denominator, we again have our integral from 0 to h of that same expression for dA, b over h times h minus y dy. I won't go through solving these integrals here or evaluating them, but we end up with 1/6 bh squared in the numerator and 1/2 bh in the denominator, which gives us h over 3. So this tells us that our the centroid in the y direction is located at h over 3. So that's approximately where h over 3 is right there. So that's the centroid in the y direction. We could do the exact same thing, or similarly, for the x direction and find that x bar is equal to b over 3. And so this is a common result for a triangle. So we see that the centroid is 1/3 from the base. And results like this are tabulated in the textbook for a wide variety of common shapes. And that is done in figure 2.18.